Welcome back. Previously, we began a new module, matrix, and we discussed about the concept and meaning of matrix, and we were discussing different types of matrices. Let's continue with that part. Next one, unit matrix. A unit matrix is actually a diagonal matrix in which each of the diagonal element is unity is said to be a unit matrix. It can be otherwise known as identity matrix and it is denoted by a alphabetic symbol I, capital I, otherwise known as small I. Try to use capital I. For the identification, I just given a small I within the brackets. It may look like number 1, that's why I put a small I. There is no abbreviation for an identity with a small I. Identity matrix is represented by capital I. Remember that part. So, this is an example of a diagonal matrix because it is a square matrix consisting of a number of rows and columns are equal, and see here the diagonal numbers. Here the diagonal numbers 1, 1, 1. This matrix is known as unit matrix. So there will be a confusion regarding unit matrix and scalar matrix. Because in scalar matrix also a diagonal matrix, here diagonal numbers will be numbers or numerics other than 0 and other elements in the matrix will be 0. Remember, in scalar matrix the diagonal numbers may be any similar numbers other than 1. It may be 2, it may be 3, 4, 5, 6, any number. But when the diagonal elements are scalar, that means diagonal elements are unit or identity. That means here the diagonal elements, see in this matrix the diagonal elements are number 1 or numerics of 1. Such matrix is known as diagonal matrix. If these diagonal elements are number other than 1, that diagonal matrix is known as scalar matrix. That is the difference between unit matrix or identity matrix with scalar matrix. Remember, unit matrix may be otherwise known as identity matrix. These terms are used synonymously. This is other representation of a unit matrix or an identity matrix when Aij equal to 1, when I equal to j, because here number of rows and columns are equal. When number of rows and columns are not equal, in that case Ij equal 0. That is just a mathematical representation of a unit matrix. You just need to remember the concept and meaning of unit matrix. Next one, triangular matrix. If every element above or below the leading diagonal is 0, the matrix is called a triangular matrix. So in a square matrix there may be numbers, means numbers above the diagonal as well as below the diagonal. Remember that concept, above the diagonal as well as below the diagonal. Since there are two concepts, means above and below, there are two types of triangular matrices. One is known as upper triangular matrices and other is known as lower triangular matrix. Let's deal with an example. A square matrix represented by a subscript ij, that is an variables written within the brackets, is upper triangle. See, let's see what is an example, what is a form of a upper triangular matrix. This is how a upper triangle matrix looks like. See, here the diagonals are 1, 8 and 2. As per the concept, any numbers that is below the diagonal matrix remains 0. See, here the diagonal is this one. Numbers below the diagonals are these 3. Any numbers that are below the diagonal matrix are 0 is known as upper triangular matrix. See, here the above the diagonals are numbers, and if we go through the formation of these numbers, see it looks like a triangle. See this one, this part. I hope you understand why it is known as triangular matrix. See, this part looks like a triangle. This is known as upper triangle. Now you will understand what is meant by lower triangular. So, a lower triangular matrix means any numbers that are above the leading diagonal R0 is known as lower triangular matrix. See, this is another matrix. All the numbers above this diagonal are 0 and the numbers below the diagonals are all numerals other than 0. So this is known as lower triangle because here the numbers below the diagonals are numerals other than 0. So it is known as lower triangle. Here the numbers above the diagonal are numerals other than 0. So it is known as upper triangle. This is known as triangular matrices. Next one, equality of a matrix. Equality of the matrix simply means similarity of 2 or 3 matrices. For example, two matrices A and B, two matrices represented by A and another one represented by B is said to be equal when A and B are of the same order. Same order means it has same number of rows as well as same number of columns in matrix A as well as matrix B. The elements in the corresponding places of the two matrices are also equal. Let's deal with an example, then you will understand the concept. For example, A is a matrix consisting of 1, 3, 5, 2, 0, 3 and 1, 7, 0. 3 rows, 3 columns. B, another matrix represented by 1, 3, 5, 2, 0, 3, 1, 7, 0. It also have equal number of rows as well as equal number of columns. So, both the matrices have same numerals within the same spaces or places within the matrix. Equal number of rows and columns and the numbers within each matrices are also similar. Such situations, these matrices are known as equal matrices or it is known as equality of a matrix. So here A equal to B. Next one, transpose of a matrix. A matrix obtained from any given matrix A by interchanging its rows and columns is called its transpose and denoted by A dash. Here it is dash. A superscript dash or A superscript T. T means transpose. Let's discuss with an example, then you will understand the concept of transpose of a matrix. We will discuss this part after discussing the example. For example, A is the name of a matrix. It is represented by 3 rows, 4 columns. So it is a rectangular matrix. See the elements within the matrix 1, 2, 3, 4, 2, 3, 4, 1, 3, 4, 2, 5. Okay, fine. And here we are discussing transpose of a matrix. See, what is the meaning of transpose? As the theory suggests that if a matrix consisting of rows and columns and the row of that particular matrix is interchanged to the column of the another and also the column of the first matrix is interchanged to the row of the another, it is known as transpose matrix. Means the other matrix is known as transpose of the first matrix. I hope you didn't understand any words. We will discuss with this example, then you will understand the concept. See, I hope you understand this matrix. It is a rectangular matrix. See, as a theory suggests, the row of the first matrix is interchanged to the column of the another. Okay, what is meant by another? Here, A is the name of the first matrix. A transpose of this matrix A is known as A raised to T. We have discussed that part in the theory. Okay. A raised to t, there is another matrix. See, another matrix can be created. How? If the row of the first matrix is interchanged to the column of the second matrix. See, here the row of first matrix 1, 2, 3, 4 is interchanged to the column of the second matrix. Second matrix is this one. This whole matrix is the second matrix. And see, here the second row is interchanged to the column of the second matrix. Here the third row of the first matrix is interchanged to the third column of the second matrix. Likewise, if you go through the columns, see here the first column of the first matrix is interchanged to the first row of the second matrix. Likewise, the rows of first matrix is interchanged to the columns of the second matrix, and the columns of the first matrix is interchanged to the rows of the second matrix. So this matrix is known as transpose of first matrix, that is represented by A raised to t. The whole concept is known as transpose of a matrix. So when you are asked to prepare a transpose of a matrix and when you are given a matrix, you just interchange the rows and columns of the first matrix and create a new matrix. It is known as transpose of a matrix. You just understand the concept. We will discuss about this part in depth in the application level. So here the same concept is represented in a mathematical form. A equal Aij. Aij means I represent row, J represent column, brackets, M into N means it is the order of the matrix. Then A raised to T equal, A raised to T means transpose equal Aj. See, here it become Aj. Earlier it was Ij, now it become Ji. Ji means J represents column because the row of the first one became the column of the second one. And the column of the first matrix became the vice versa of the another. That's why the alphabets has interchanged. This is a mathematical representation of all this theoretical part. This is known as transpose of a matrix. We will discuss in detail in the application. So as per this matrix, here it is expressed as A equal to Aij into 3 into 4. And transpose of first one is represented by Aji into 4 into 3. Here the row became the column of this one. That's why it is written. I hope you understand the concept. Next one, symmetric matrix. Any square matrix A is said to be symmetric if it is equal to its transpose. Just now we discussed about what is meant by transpose of a matrix. So, what is meant by symmetric matrix? We will discuss with an example. This is the easy concept. A is a symmetric if A is equal to AT. We know what is meant by A. A means the name of a matrix. And AT means transpose of this A. So when will we write A equal to AT? When A and AT are equal. And we had already learned what is meant by equal matrices. We will discuss an example. See, consider a matrix A 2, 3, 3, 5. This is an order of 2 into 2 matrix. So transpose of a matrix means 2 here row will become the column of the second matrix. And the column of the first matrix become row of the second matrix. So if you take the transpose of matrix A, then the transpose of this first matrix remains the same as the first matrix. See, here first matrix is 2, 3, 3, 5. And its transpose looks like same the number, same level. Rows and columns almost same, and even the elements within the matrix also same, even after interchanging the rows and columns. So whenever a matrix and its transpose is generated, the elements of the first matrix and its transpose remains the same. Such matrix is known as symmetric matrix. So we can say if the situation where A equal to A raised to T, that means the first matrix is known as symmetric matrix. I hope you understand the concepts which we have discussed till now. Just go through the theoretical part which we have been discussing in the previous class as well as today's class. Just understand the concept, familiarize the terms, what are the nature, properties, meaning, concept. Just go through it. We will discuss further cases of the matrices in the next class. That's all. Thank you.